Alright, this video is on the objective: analyze a hypothesis test and make conclusions. It's number 2, so I've already done a video on this kind of problem, so I'm not going to go into as much explanation as I did in that first video. I'm just going to kind of work through the problem and explain things out loud here. So let's take a look. So here, a social media content associate who works for a growing startup business is looking for ways to use social media platforms to build an audience. It is known that the average number of social media posts per day that helps to build an audience is 3 daily posts. So like mu equals 3. Yeah. After posting on social media for a few months, the social media content associate claims, states that the average number of social media posts per day that help to build an audience is different, not 3. Alright, so that would be the alternate hypothesis that doesn't involve equality. So mu is, not equal to 3 would be the alternative hypothesis. The average number of posts is not 3. And then the opposite of that, the one involving equality, mu equals 3. And the null hypothesis will always involve equals. Right? Okay, and so these are the hypotheses. Mu equals 3 always equals for the null. And then, again, so the alternative is the claim, right? The belief. They believe, this person believes the average is different than 3. So the claim is here. This is the opposite of the claim. So let's take this into account. Now there's going to be a second part to this question. Again, please read through your answer explanations and stuff, of course, to make sure you know what's going on, and especially if you got it wrong, to see if you can figure out where you went wrong. Now, using the information obtained from the previous study about social media posts, the following data was obtained for the hypothesis test. So again, null hypothesis, the average number of social media posts to build an audience a day is 3, whereas the alternative is that it's not 3. It could be less than 3, greater than 3. So remember, it could be less than 3, could be greater than 3. So this is a two-tailed test. Remember, the way the alternative hypothesis looks tells you what kind of a test it is. And we're using a significance level alpha here of 1%, 0.01. Now here's something that's given to us that we're normally going to have to calculate ourselves, and you're going to see in future videos and future sections. We're going to do this ourselves. We're going to take a sample, find the mean for that sample, then find the z-score or the t-score, for that particular sample mean in the distribution of sample means. So that was done for us here, and they told us, the z-test, the z-test statistic, the z-score for our sample mean, negative 1.17. All right. What is the p-value and conclusion for this hypothesis test? All right, so I'm going to go to a piece of paper here. Now I got a calculator up because I'm going to show you, how to calculate the p-value with our calculator, and then we're going to go look at what they have. So we're working with the standard normal distribution because they told us, z-scores, right? It was a z-test statistic. So I'm looking at the standard normal. All right, that was pretty crappy. But then underneath the middle, you got 0, right? Z-score of 0. And this would be the z-score of, mu equals 3, right? We assume the null hypothesis, right? We assume that the null hypothesis is true, that the mean number of social media posts to build an audience is 3. And that'll have a z-score of 0, right? So like this middle here kind of represents, mu equals 3. Then the z-score for our sample, right, our test statistics z-score, they said was negative 1.17. That'd be over here somewhere. So so the sample mean, so there's the test statistic. So that means our sample, whatever this, again, they didn't give us the information about the sample, but whatever it was, our sample's mean was 1.17 standard deviations below 3, below the population, the assumed population mean. And now the question is that so far away from the middle that our assumption's probably bad? Like, because if we assume this, you know, you'd expect a lot of the bulk of the data. You'd expect if we took a sample, its mean would be pretty close to 3. But we took a sample and, you know, it's out here. Is this so far away that it's like, ooh, maybe the mean isn't 3? You know, maybe I should shift it. So let's do this. All right. So now that, you know, this test statistic is below the mean, so I'm going to find the area to the left of it. So find this area, and I'll do that with a calculator. Now, for the p-value, remember we're doing a two-tailed test here, right? The alternative hypothesis was mu is not 3. So a two-tailed test, remember for a two-tailed test, the p-value is twice this area, right? If my test statistic is to the left of center, to the left of the mean, I find the area to the left and then double it. If it was to the right of the mean, I'd find the area to the right and then double it. All right, so let's find this area to the left of this value. Now again, hopefully you remember how to, I already got some of it up here. Remember second distributions, normal CDF to find areas under normal curves. There is no left bound here. There is no lower value, so I'm going to put some big negative number. So I got the negative sign down here, negative 9, 9, 9, 9, 9. Let's go another 9, why not? And then the upper value in this region is negative 1.17. And please be sure to use the negative sign, not the minus sign. That's only good for subtraction. And then mean 0, standard deviation 1. This is the standard normal. So this area is approximately 0.121, a little over 12%. So the p-value for our test statistic then is approximately double that. So approximately 0.242. And I'll just go times 2 here for the p-value. And again, the only reason I'm doing this is because it's a two-tailed test. Right? That's the only reason I'm doubling this area. Now, compare this to alpha, right? The significance level was 0.01 for this particular test. The p-value is definitely bigger than alpha. 24%, definitely bigger than 1%. And remember, if that's the case, then that means our sample mean, our test statistic, isn't that far away from the middle. So I'm okay assuming this. I'm okay with a mean of 3 then, because our sample wasn't that bad off, wasn't that far off. If the p-value is greater than the significance level, if the p-value is greater than alpha, you do not reject. You fail to reject the null hypothesis. All right, so you had the null hypothesis was the mean equals 3. The alternate hypothesis was the mean is not 3. You're actually okay with this. I'm okay with this, right? We're not rejecting it. Meaning that, remember this was the claim here, right? The alternate hypothesis was the claim, the alternative. Meaning we're not okay with the claim. Our evidence does not support the claim then, because we didn't reject the null. We didn't lean toward the alternative, which was the claim. So we could say that our evidence does not support this person's claim. That's another way to word it, or say there's not enough evidence to support the claim or whatever. All right. So back here. So they having us moving some stuff. Now I said it was a two-tailed test because of the way the alternative hypothesis looked, right? It was mu is not 3, so I move it down here to this two-tail guy. Now you see they gave us a rejection region. This purple region are the rejection regions. If you were doing like a critical value method, I move the significance level. Oh, it's already at 1%. All right, so the area of this and this is 1% total. That's why they're saying C alpha over 2. The area over here is 0.5%. The area over here is 0.5% to make a total of 1%. So we have our purple rejection regions. And then I just move the test statistic to where they said it was. It was negative 1.17. So I move this red dot over to negative 1.17. Oop. Yes. Okay. And then look, see the p-value? The p-value is this pink area. The area to the left here doubled. See how they have it doubled over here? They just took the area to the left of negative 1.17 under the curve and doubled it. The p-value, and that was on my calculator, right? That was point. You see it here? 0.242. Right? I had that. But, just look at the picture. Now, again, the p-value definitely greater than now alpha is 0.01. 0.242 definitely greater than 0.01. If you were doing critical values, the critical values, the entrances to these rejection regions is 2.58 and negative 2.58. The test statistic is not beyond those. We're not in the rejection region. So again, either way you look at it, whether you're looking at critical values or p-value, you're not in the rejection region. You do not reject the null hypothesis. So the p-value is 0.242, which is the second or third option here, and we don't reject the null. So that means the social media content associate does not have evidence to support their claim that the audience, they need more than a different number than 3 daily posts. And again, read your answer explanations, please, even when you're correct. Just to double check, make sure the reason why you were correct is understood. But especially read them if you're wrong. Right? Make sure you can figure out where you went wrong, and hopefully do better the next time you see a problem like that. And hopefully, I have 2 videos up on this, right? 2 videos on problems related to this objective. Hopefully they help you when you're working on it on your own. And thank you very much for watching.